My talk is titled Touch Panel Design Considerations. We're going to use a glass-glass construction for this presentation, basically for two reasons. One, Ocular really focuses on that, so that's what we're most familiar with. And second, it gives me a chance to sort of talk about the various options in terms of cover glass, in terms of bonding materials, in terms of agents and films that you might get on top of the cover glass, and all those kinds of factors that are going to be important when you're designing in touch panel into your application. For cover lens material, first of all, there are a multitude of options for all of the things I'm going to talk about. So I'm only really going to hit sort of what's most popular, what's most common, what do we get asked the most about. For cover lens material, you can obviously have just plain soda lime glass. Comes in a variety of thicknesses. We can pick whatever thickness is going to work. Again, some of our customers want to go thicker because they're worried about durability. Some of our customers are asking for 3mm, 4mm cover glasses. The only issue with that is the thicker you go, the less sensitive the touch panel becomes, unless, of course, you adjust the touch panel either physically or in terms of a configuration to help compensate for that. Take plain soda lime glass, and you can do chemical strengthening on top of it, CS glass. That makes it a little harder. Actually, what it really does is make it less scratch resistant. The next option might be a super or premium glass, aluminum silicate glass being the primary example. And then finally, of course, you could have a plastic, PET, PMMA, those kinds of things. Our customers typically want those kinds of materials when they're worried about impact resistance. Now, I mentioned a minute ago about the various glass strengths, or what's hard and what's not. And there's actually quite a bit of confusion, at least with our customers, on this issue. A lot of people will talk about an H number. What's the H number for your glass? What's your Mohs hardness scale? And the difficulty here is that people think of that as equivalent to an impact resistance. I want to make sure my glass doesn't break when I drop it, so I need a 7H or an 8H. Well, that's not really the right number to be using for that. Mohs hardness is really a definition of how scratchable your top surface is. So how do you measure impact and durability? There's a whole range of different numbers that people talk about. Vickers scale, Mohs scale, this, that, the other. One of the best things to focus on is a ring-on-ring test, because this really tells you whether or not the glass is going to break under certain conditions. A ring-on-ring test, conceptually, you can think of it, even though it's not practically done this way, you can think of it as basically two concentric rings, one slightly smaller than the other, and you put your material, glass, in between them, and then you start to press down on the top piece of the ring until finally you get to a force that breaks the glass. And at that point, you have your ring-on-ring number. But the key thing is, don't talk about hardness if you really want to talk about whether it's going to break, because it's not really the same thing. Another important factor for us, for the touch panel maker, is the dielectric of the cover lens. The dielectric constant is basically, or it's technically, the relative permittivity of the material. And what that really means is that it tells you how well an electric field is going to propagate through that material. So a higher dielectric means you get more propagation of the electric field. One of the key things that we have to make sure our customers understand is you can't just go swap cover glass. You can't take a touch panel that's designed for a 1mm piece of soda lime and put on a 1mm piece of Gorilla Glass and expect to get the same performance. Sapphire. This is a really exciting new material for cover lenses. Sapphire's number 9 on the Mohs scale, right below diamond. So it's extremely tough, extremely durable. Because it's that high on the Mohs scale, because it has a very dense structure, it also makes it very break resistant. So you can drop it, step on it, whatever, hit it with the rock, and it's generally not going to break. The next thing that a lot of our customers are asking for nowadays is coatings and films and other kinds of treatments that they can do on the cover lens. Outdoor applications and anti-glare, anti-reflective are becoming more and more important. The most common ones really are anti-glare, anti-reflective, and anti-smudge. Anti-glare is typically an etch process. So you take the top surface of the glass and you put some kind of acid on it, and it creates this little striations, or sort of bubbles in a sense, micro bubbles in the top surface. And what that does is it diffuse the incoming light. So as a light ray comes in to the glass, it doesn't just exit right back out at the reflection angle. Instead, it gets diffused by this various surface pattern that you get. And that gives you much less glare coming off of the top surface. Anti-reflective is sort of similar. Here what you're doing is typically an electrovapor deposition process of a material. But again, what you're doing is altering the top structure, the crystal structure of that top surface. So in this case, as light comes in, it gets reflected back, but it gets reflected back at different angles, so you get destructive interference. So you get a little anti-reflective value out of that. And then the third, again, most common is anti-smudge. This is typically two different materials combined together. What these materials do is they change the surface tension of the top surface of your glass so that if you have water or oil on your top surface, the water and oil tend to bond together instead of to the top surface. So we end up with our little beads of water or little beads of oil instead of, big spread out pool. The big benefit really to these is that it makes it so much easier to clean them off. We have some marine applications we've done with salt water. And again, the whole idea is you put the water on it, you go like that, and the salt comes right off with the water. It's nice and clean. So the great thing about these is you can add whatever coating or film you want. It's not really going to affect the touch panel from a performance standpoint. Bonding layers of the individual pieces of the touch panel are also important. So you could have 3, maybe even 4 separate bond layers inside of your touch panel. And those bond layers have to be index matched to prevent refraction. But again, that's one of the things y'all don't have to worry about. It's something that the touch panel vendor has to worry about, make sure they get right. Now, there are generally 2 types of bonding adhesives. There's wet bond and there's dry bond. A wet bond is a viscous liquid kind of material that usually gets squirted on and is then cured through some kind of process, usually a combination of UV and heat. Then the other example would be a dry bond. The most common version of this might be a sort of, think of it as like a double-sided sticky tape. There's a substrate, typically PET, and on that substrate are adhesives on either side. And so we put down that adhesive substrate on top of one surface and then take the other surface and stick it to it. The other option is what's called no-base adhesive. And in this case, you take out the PET substrate and all you have is just a sheet of adhesive. So you put down your, same process, you put down your bottom surface, you put down the adhesive, you put down the top surface. But these are sort of self-curing. Now, one of the reasons this matters in terms of whether you have a PET substrate in your bonding agent or not is for outdoor applications. Birefringence is a process that occurs when you have 2 factors, and you have to have both of these factors. First, you have to have material in your touch panel that is birefringent, and that means that it reflects the wavelengths of the light at different angles. And so, in a sense, it's sort of like a prism. It splits the light up into various directions. You also have to have a polarizer in front of your face. So polarized sunglasses being a prime example. What that does is it allows you to see only one angle of the light coming at you. And so once you have done that, now you can see the individual prism effect of the light rays. So when you look at something that has birefringent material in it with polarized sunglasses on, you start to see sort of a rainbow effect. If you are working on an outdoor application, that's something you need to make sure that your touch panel vendor knows so that we know that we need to design it that way. The last thing you need to worry about is mechanicals. This mainly has to do with how you can mount the touch panel, what size is it going to be, but also has to do with where the FPCs get routed in the system. How do they get routed around? Are there any keep out areas, any constraints, etc.? Thank you.